Who knows what this means? So this is a little precursor to the notes that I gave you. So these are not on there. But if you know how to do this, it's up to you. Greatest common factor. So, okay, y'all are good with acronyms. What does it mean? That they both share. So the biggest one, what does it mean to be a factor, I guess is what I'm getting at. Divide by with no remainder. It goes in evenly, right? So if I asked you for the greatest, not to be confused with greatest common multiple, right? We know the difference in the greatest common multiple and greatest common factor. So if I told you, if I gave you the numbers 15 and 75, what would be the greatest common factor?
15.
Does 15 go into 75?
It does.
Yes, it does. So the biggest number that you can divide them both by, we all understand that, right? Okay. How about, because you know I'm going to make it a little harder than just that. What if it was 20x squared and 75x? Now what's the greatest common factor?
X.
Yeah, an x, yes, but also a 5x. Do we all agree with that? Okay. Well, because, so you can divide both of the coefficients by 5. That's the greatest common factor of the coefficients. But then if you look at the variables, so there's 2 x's and there's 1 x. So I could definitely divide by an x and be left with a whole number. In other words, take an x out. Yeah.
So what if there was 1 x on each side? Could you still have 5x?
So if there was, like what now?
If it was like 20x instead of 5x instead of 3x squared, just 1x in there?
Like, you'd still take the x, yeah. You'd still take the x.
So it's still be 5x. 75 x squared and 5x.
Correct, yeah, yeah. You can't take any more than what the one with the least amount has. Does that make sense?
Yeah.
Yes. So, guys, this is important. If they both had x squared, then yes, the GCF would be 5x squared. Okay, because they share the x squared. Now let me take you back, rewind you back to what? You sure? Okay. Let me rewind you back to whenever you learned. This was probably algebra 1, maybe pre-algebra. Did y'all do pre-algebra or you did like? Okay. What if I had this? Okay, and now I'm not talking about GCF, but I'm wanting to expand it some. And I'm seeing your finger. That's exactly right. Distributing, right? Distributing. So 2x times x is what? 2x squared. And 2x times 3 is?
6x.
Now, I want you to look at something for just a minute. I want you to look at these two terms. What is the GCF of those two terms? 2x. Notice before we distributed, that's what was on the outside. What we're going to be doing is we're going to take it from the right side and make it look like this. Okay? Or, you've probably factored out a monomial factor like that. What you have not done is taken something that looks like this. If I foiled that out, some of you said yesterday you couldn't remember how to foil. Was that this class or fourth block? Okay, so if you take the first term and it distributes to everything in the second set of parentheses. So x times x is, and x times 2 is, and so I'm done with this first piece. Now I'm going to go to the 3. 3 times x is, notice how I'm just taking everything in the first parentheses and distributing it to everything in the second parentheses. And then 3 times 2 is 6. So gather your like terms. 2x and 3x is. So what you have not done, you've probably gone from here to here, but we're going to be going from here to here. Okay?
Oh, we've got from here to there.
That's factoring, okay? And there's some There's some steps that go along with this. You're going to have to be able to do this first part also. And so that's why I wanted to take a minute, because some of them will have a GCF that we'll have to take out before we factor. Okay? All right, y'all ready to jump in? If you can GCF, what? Let's dive in. Okay.
Miss McGee's lifeguard, don't worry.
Oh, Lord. All right, if you can GCF, you can factor. All right, so as long as you can GCF, you're going to be fine. We're going to practice until you can. Okay, so let's start easy. Let's start a GCF, and let's see what happens. Let's say I had 6x squared minus 18x, and I asked you to factor out the greatest common factor. Okay. 6x is the GCF, right? So don't just divide the numbers, because that's what everybody always wants to do, but look at the biggest thing you can divide them both by. Okay, so you can, 6 will go into both of them evenly. So I know I can take out 6x, right? So if I'm backwards distributing, that means I'm not multiplying, I'm dividing, taking it out of it, right? So what's left here? X. In other words, whenever I distribute, what do I need to hold the place to get 6x squared back? How about the second spot? 3. Do you see what we're doing? How we're... Okay, we're just taking out the GCF here. We're backwards distributing is what we're doing. Does that make sense? Kind of? Okay. All right, so if this is my GCF, right? So I took the GCF out of 6x squared. In other words, I divided it. And what's left is just an x. And then if you divide the negative 18x by the 6x, you're left with a 3. So that if I were to come here and distribute this back through, I'd still end up with the same thing I started with. Okay. One more. Una más. What? 6 must be the number of the day. My brain keeps going to 6. I'll do 8x to the third plus 12x squared minus 4. Okay. So it's 4. And I want you to be in the habit of the first step of factoring is always, always, always looking for a GCF, okay? And taking it out if you can. So here, y'all said 4. And actually, I'm going to do this. I want you to see what happens when there's an x. So now it's 4x, right? Okay. If you take out a 4x, what's left? In other words, when you divide, look at the first term.
8x squared.
2x squared.
Oh, yes, sir. And a 1.
And a 1, because it's still, yep, it's got to hold the place, because if I distribute it back through, I need to be able to get a negative 4x on the end. Everybody okay on that? No? Let me see. It's 5x, because they also all have an x. I'll write it under this. Maybe it'll be a little easier for you to see if I write. Come on, pen. If I write it under. So it's 5x. What's left of this term?
3x squared.
Minus 5x. And now this one I would need a 7 when I divide it. So you're just dividing. That's all you're doing really is dividing. Dividing the coefficients and taking away the number of x's that you took out. All right. So now we're on to your factor by grouping. So I haven't always taught factoring by this method. There are a multitude of different ways to factor. They all essentially do the same thing. It's just how it looks as you do it and what makes more sense. This is probably the closest to what you'll do next year. It's Miss Wilson's favorite, so I picked it up because I used to use the box, and I still use the box in my CP class, but if she ever gets to factoring, she shows y'all this. I take it she didn't get to factoring because y'all would look at me like you've never heard this before. Okay. But it's logical. I was going to say, I think one of the classes she introduced it because we talked about, she said, how do you want me to teach it? And I said, if you get to it, teach it, and then I'll pick up whichever way you do it. It doesn't matter. So she got to it in one class at some point. All right, so here's what we're going to do. Our directions give us a trinomial, and this is the one that's written at the top of your paper. Okay? All right, so your first step always in factoring is to look for a GCF and take it out if you can. Now, they won't all have a GCF by any stretch of the imagination, but a lot of them will. Of course, I started you one here that does, so you can see what happens if you have to take out a GCF. So what's the GCF here? 2. All right, when you take that out, you're left with 6x squared I like to think about factoring as a puzzle. If you think about it like that, it's kind of fun. If you look at, so looking at this, and we're just going to look at what's in parentheses, because remember the goal is to get it in 2 separate parentheses to look like intercept form. So, tell me first, what is A? What's B? What's C? Here's the puzzle. Multiply A times C together. What do you get? You need to find 2 numbers that multiply to 12. And now if there are negatives thrown in there, you have to take that into account. So we'll do several with negatives in there and all. All right, it's got to multiply to 12, but when you add them together, it must give you 7. Okay? So, it must multiply to 12, but add to what's in the middle. So what? 3 and 4.
Yes.
Okay. 3 times 4 is 12. 3 plus 4 is 7. Okay? That's the puzzle. To me, that is the hardest part of factoring, is finding those 2 numbers, okay? And this is an easy one, so obviously, but I mean, when that A times C gets big and you start having to find the numbers, it gets a little more difficult, okay? All right, there it is, 3 and 4. We all in agreement? We're going to rewrite 7x using 3 and 4. Because remember, they add to 7. So we're going to change it. Instead of 7x, we're going to say 3x plus 4x. The order doesn't matter. Okay? So essentially, if you think back whenever we FOILed out, remember we had to combine like terms after we FOILed, and we're backwards FOILing now, so we're going backwards order. Okay? Now, I always tell my students at this point, slash it. We're going to look at it as 2 separate problems for the time being, okay? The 2 stays outside. It's just there. Look at these 2 terms. What is the GCF? 3x. If you take a 3x out of those 2, what is left? 2x plus 1. Is everybody in agreement there? I'm just writing things different ways. I'm not really doing any math with it. I'm just writing them different ways. Always keep the middle sign. And now look at the last 2. GCF?
2.
What's left? Tell me this, if they didn't have a GCF, what's always a GCF? 1. You can always divide stuff by 1. Keep that in mind because that'll come up too. Now as you look at this, now here's where you have to really think about it conceptually. Do you see, looking just in this big parentheses here, do you see something they have in common? A big GCF. 2x plus 1. Okay? What I'm going to do is I'm going to take a 2x plus 1 away from both of them and put it in the front. In other words, I'm going to take this, and what's left? plus 2. So if you were to take that whole 2x plus 1 as one big piece and distribute it to the 3x and then to the 2, you'd come back to what you had before, right? The 2 is still outside, and it is now factored. How would you check to see if you're right? Foil it out, distribute through.
Why would you ever do that?
Oh, just wait. I think that is the essential question of Algebra 2.
Why do it?
Why should I factor?
Well, why should I learn this?
I mean, it is all, every single chapter comes back to factoring. Like, we use factoring.
No, I'm saying, like, why would we ever use this in the
These are, so this is a lot to do with quadratics. We'll actually do a lot of application type word problems with these. This is what I was telling you yesterday, where you like maximize profit, minimize cost. Those are all quadratic type functions. Minimize area or maximize area in a box, finding dimensions. There's a lot you can do with it. All right. If you flip over to, there's some tips at the bottom of your sheet. Okay. Let's flip over to the back and let's do these together, though. Is there a GCF? One. So I'm just going to move on, okay? When you'll use the 1 is when we're grouping in the middle and stuff. All right. What is A times C? 5. Can you think of 2 factors that multiply to 5 but add to 6? 1 and 5. Wait.
You said multiply.
Multiply to 5 but add to 6. 1 and 5. All right, so I'm going to rewrite 6x using 1 and 5, right? X squared plus 1x plus 5x plus 5. It's the same expression. It's the same quadratic. I just broke that middle term out a little bit. Slash it. Yes, always. Why are you taking a test over here? No, I'm just kidding. GCF first 2, what is it? 1x. If you take that out, what is left? Middle sign? And GCF here, I think that's what y'all were saying, 5. What's left? Notice how the parentheses are exactly the same. That tells me I can take them out just as I would any other GCF, and it goes to the front, right?
What happened to the parentheses are not the same? Did you do something right?
Then you didn't do something right, yeah. I'm glad.
It was already good.
Yeah.
No, I mean, ours did too.
You know when you say 1 times 5 is 5, I was going to wonder.
Yeah.
Where did the X and Yes.
Well, because it's got to add to 6x, so 1x plus 5x is 6x. I got to keep everything the same value. I can't change that, but I can write it a different way. What's left here? Okay. I will tell you this. The ones who have a coefficient, a leading coefficient of 1, in other words, the ones whose A's are 1 are the easiest to factor because it always, always, always comes out that these 2 numbers are the numbers here.
It's
Okay.
always find nothing.
If this is a 1, okay? But like the first one that we did, we did was 6x squared plus 7x plus 2. That's not 1, so it doesn't work like that. You have to go through the grouping steps.
can we do that?
Yeah, if you recognize it as that, sure.
Hold on.
There's not going to be a lot that are like that, but yeah.
I mean, it's like,
No, because so what happens, think about it like this. If this was xy plus 5y, okay, you would take, if you had xy plus 5y, the GCF of those two is y, right? So you take it out, and what's left would be x plus 5, right? I'm just replacing the y with x plus 1. It's the same kind of concept. Yeah?
Wait, how did you get the x plus 1 from the second step to the third step?
This one?
Yeah, no, the one right above it. So you go from that to then you get that x plus 1.
So I looked at the first two and I took the GCF out. And then I looked at the second two and took the GCF out. Let's have some negatives in here. What you think? What's A times C? Negative 12. What multiplies to negative 12? Yes. If it multiplies to a negative number, then I need one negative, one positive, right? That's the only way to get a negative when you multiply. I will tell you it's easier if you start with your negative number in your equation, in your expression when you're factoring. Okay? When you rewrite this, you do minus 6x plus 2x minus 12. Everybody okay on that so far? All right, GCF of the first two. What's left? GCF of the, remember, first, middle sign, GCF of the second two? What's left? What goes in front? X minus 6. And it really doesn't matter which one you start with. I just always think about it as pulling the GCF out, and you're left with x plus 2. Again, notice, because the leading coefficient was 1, that was an easy factor. Yeah. Let's make it harder. I'm nurturing and growing brain cells.
I'll look at the next one.
I'm so lost.
Oh, zero.
0. I need a 0 in the middle because there is no B. But that also means, do what? Now this one does have a GCF I could take out before I even started. Did you see that? I would probably do that. Let me do that.
Yeah, let's do that.
Because 4 times 36 is big, right? All right, so let's do 4 times, what's left if I take out 4? I'm going to put this 0 in the middle so you can visually see what's happening. Minus 9. What's it multiply to? What's it got to add to?
It has to add to. It has to add to 0. 0. No, negative 3 and negative 3. Negative 3 positive 3.
Good job. What's negative 3 plus 3?
0.
What's negative 3 times 3?
Negative 9.
It's a puzzle. What?
Oh.
It's fun.
No, it's not.
How did you get the first negative? Is that from the X?
A times C, 1 times negative 4. I mean 1 times negative 9.
1x squared?
Remember, A is just the coefficient. A, B, and C don't have x's on them. They're just coefficients. Slash it. GCF the first two?
Oh, wait.
X. X minus 3. Middle sign. 3. And then get rid of the x minus 3. Which leaves us with, I love factoring. love, you'll get so good at fact. Everyone in here will get so, despite how you feel, I promise, despite how you feel today, you will get so good at factoring, it'll be second nature to you.
I hope so, because right now, that's just not what
This is the first time you've seen it now.
I showed up like 2 minutes.
I saw it in 8th grade.
But you were here with us.
How is 8 times 2?
Because A is 1, B is 0, and C is -9.
Let's address that scenario.
Let's address it. Let's do it. I love your enthusiasm. Okay, look. We have not addressed, remember how I keep telling you to keep that middle sign? That middle sign keeps being a plus. Oh, what if it's a negative? Great question. Let's look at that. GCF here? Because remember that's the first step always to factor. 2, what's left?
X squared minus 7 plus 7x plus 6.
A times C is?
6.
I need it. Good job. It's got to multiply to +6, but if I look in the middle, it's got to add to -7.
Are those going to be the numbers?
Yes.
I had to make sure.
Okay. Now, I want to walk you through this one grouping, even though you could shortcut this one, because there's something special with the signs that happens that comes up a lot. All right, x squared. I'm rewriting 7x as -6x negative. Why'd I put a comma? Oh, come on. All right. -6x minus 1x plus 6. And, right? It doesn't matter which one goes where. All right. What can you take out of the first two? What is left? Okay, my pen's thinking about writing. That's right, you're right. Okay. Middle sign is minus. What is the GCF of the second two? 1. Are you saying 1 or are you saying wait? Okay. Now, understand, because there's a minus in front of 1, essentially what I'm factoring out is -1. Okay? So when I distribute, I've got to make sure that this would come back to be a positive. Yes. When that middle sign is negative, it forces that last sign to change. Because really you're factoring out a -1. So when you remember, the goal is when you distribute, you come back to what you started with. So if I had a plus in the middle, I'd have -6 here. Okay? So that's the tricky part, is when the middle sign is minus, it changes the last sign. Okay? So now finish factoring it. What's the common factor here?
X minus 6.
X minus 1.
Well, that would be like 2 different. Like x minus 6, and then like an x minus 7.
Oh, if it is, you're talking about the next to the last step. If it's ever like that, you've done something wrong, because if you can find these two numbers, then it'll factor. Because A is 1 and C is 6. I'm looking at just the parentheses, not the beginning problem. After you take a GCF out. I wanted y'all to have a fun-filled weekend, you know? Just wanted y'all to try this one on your own. There could be. Do you just read my brain while I'm up here? You're ruining all my surprises, Corbin. God.
What you doing right now?
Is this like the answer is like
N/N.
Well, since Corbin already told us. All right, so I was really putting this one up here to trick you a little bit, since I'm so mean. A times C is what here? Negative 18. So what two numbers multiply to negative 18 but add to negative 9? Oh, wait. All right, so I hear negative 6 and positive 3, but those add to negative 3, so that doesn't work. Then I heard negative 6 and negative 3, but those multiply to positive 18, so that doesn't work.
We're gonna have to go to a higher row.
after this point, I'm gonna give up anyway. So there's no
It's gotta be a
that's
big
what I
number.
need to do.
Acronym masters cannot be factored.
That was my favorite acronym.
Now listen.
That's my favorite acronym.
I am going to knock some of y'all's heads like coconuts if y'all come in here and all your homework when you come in says CBF, 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 because there are very few, very few that are CBF, okay? I'm hesitant to even show you CBF but there are a couple that are CBFs.